Question number 28. We need to find the current through the resistor R in the figure 45-E60, E6, whatever. If this resistance R is equal to 12 ohm, and the second case, this resistor R is equal to 45 ohm. The key thing in this circuit is this diode here. And the first thing we need to see is if this diode is forward bias or it is reverse bias. If the potential at this point is higher compared to the potential at this point, then this diode will be forward bias. And if this potential is higher and this potential is lower, then this diode will be reverse bias. And in the problem here, we have given that for the problems 25 to 30, assume that the capacitance, the resistance of each diode is 0 in forward bias and infinity in reverse bias. So depending upon if it is forward biased or reverse biased, we can either replace it with a wire or just remove this whole circuit, because this is open circuit, infinite resistance. So the first thing we will do is mentally remove this whole thing from the picture and consider these two cells which looks like a cell with two internal resistance. And the equivalent, if we know that I should have another video on this about the equivalent battery and the resistance of several cells connected in parallel. So basically we have 4 volt here and 12 ohm resistance here, and then connected with a 6 volt battery. In some problems they have shown it wrongly. So let's say the first part where R is equal to 12 ohm and this is 6 volt. Now this whole thing can be replaced with a single battery and an internal resistance, where this battery voltage V, or let's call it E, is equal to sigma EI divided by RI. Write it complete again. Sigma EI divided by RI divided by sigma 1 upon RI. What it means? What does that mean? Let us assume that our assumption says that this battery here is positive, which will mean that any battery that aligns with our assumed direction will be taken as positive. Any battery that is against our assumed direction will be taken as negative. So this battery will take as positive, this battery will be taken as negative in our calculation. That is the convention of the sign. If we get the result that our E with this assumed result is positive, then we will assume that our assumption was correct. If we get E as negative, then the direction of the battery or the resultant cell is like this positive and this negative. So let us calculate this. We should have a derivation in some other problem. It's sigma EI by RI is, this is 4 volts. Sorry about that. So this is 4 divided by this resistance 12. And now this one will be taken as minus 6. This is minus 6 divided by this resistance 12 divided by sigma 1 upon Ri is 1 upon 12 plus 1 upon 12. Now this thing becomes 4 minus 6 is 12. 4 minus 6 is minus 2. Minus 2 divided by 1 plus 1 is 2. So this becomes equal to minus 1 volt. Now the current is reverse to our assumption. So in reality what we have is actually the battery is like this. This is positive, this is negative, and this is internal resistance, and this is connected to a diode of this thing, something like that. Now this is negative voltage at here and a positive at here. That means this is in reverse bias, so this circuit can be removed because this is open circuit. So what we have really is only this circuit. There is no diode here, and and now we know that we can find the current in this whole circuit using the Kirchhoff law. And the Kirchhoff law, let us say the current flows in this direction. When the current flows in this direction, then we on the right hand side we will write all the batteries 6 volt in the assumed direction, and this also is battery in the same direction. These and these cells are in series with positive connected to negative, so this will be plus 4 volt equal to, if I current is flowing into this, then the drop will be 12I plus 12I or 24I. So I is equal to 12 divided by, or 10 divided by 24. This we can write as 5 divided by 12, or 12 into 4, 48, 20, approximately 0.42 amps. That completes the part 1. So in this one, all you need to know is whether this diode is forward bias or reverse bias, and that's why we calculated the equivalent battery voltage. In the second part, we have this is 12 volt, this is 4 volt battery here, this is 12 ohm, and this battery is 6 volt, and this is 12 ohm. Now in this circuit the equivalent this is 48 ohm. The equivalent battery is E. Mentally remove the diode for the moment and focus on the voltage difference between this point and this point. Let us say this voltage is in this direction and it is replaced by another cell and another resistance. And this EMF E, equivalent resistance EMF E, is equal to sigma EI by Ri divided by this whole sigma divided by sigma 1 upon Ri. So 4 divided by 12, and this is minus 6, this time it is 48, divided by 1 by 12 plus 1 by 48. This becomes 12 into 4, 48, 4 into 4, 16, 16 minus 6 is 6, divided by 48, divided by 12 into 4 is 48, 4 plus 1, 5 by 48. 48 cancels, we have 16 by 5 volt. So effectively, we have a battery of 16 by 5 volt and a resistance, internal resistance, which means that this diode is forward biased. When this diode is forward biased, you can think that this whole circuit is connected and the resistance here comes into effect. Now in this situation, we need to find out this current I. So to do that, we have this circuit over here that I have calculated earlier, so I will just go ahead and present that. We have a 4 volt battery here and a 12 ohm resistor, and then 6 volt battery here. This is current I1, and this is one we need to find, so we will keep this one as one of the variables. The other variable, let's keep this current coming out of this battery as I2. So I1 current comes here, I1 out of that I2, I1 goes here, so the remaining current is I2 minus I1 flows into this 1 ohm current or 1 ohm resistor. So we have two loops for the Kirchhoff voltage law. Let us take this one as our first loop. In this loop, we have one voltage source trying to throw out the current in this direction. So we call it 6 volt. That will be equal to the IR drops in this direction across all the resistors. So IR drop on this resistor will be 48 I1. When we move on to this one, our assumed current is flowing in this direction, so we will have a negative sign here. Negative of I2 minus I1, and they have given this resistance as 1 ohm, so multiplied by 1. We simplify it, we get 48 I1 minus I1 is 47 I1. Minus plus I2 is equal to 6. We can get the second equation from this loop. In this loop, or maybe better if we take this loop, this bigger loop. This is also a Kirchhoff loop. Sometimes it is convenient if you take an outer loop. It does not look a little odd, but this is also a loop. And in this loop, we have a 4 volt battery trying to drive out the current in this direction. Because of this, we have a voltage drop in the same direction as this, so it is I2 minus I1 multiplied by 1. And then when you move on to this 12 volt, this has a current of I2 flowing in the direction of our loop. So this will also be positive 12 into I2. I1 and then 12 I2 minus I2 is plus. So seems to be some mistake here. So I1 plus 11I2 is equal to 4. 12 minus 1 is 11 is equal to 4. Now we need to solve this and this equation for I1. So we need to eliminate this for I2 get I1. So we multiply this by 11 and subtract this one from this one. So we have 47 multiplied by 11 and this becomes minus 1 equal to 6 into 11 and this one will become minus 4. So this becomes 66 minus 4, this is 62. 62 divided by 47 multiplied by 11 minus 1 will be approximately 47. If you calculate this whole thing, you should be able to get the desired result of our I1.